fan there, we have that yellow cable connecting our primary to our neutral. That is our personal ground. Anytime that a lineman is working on the line de-energized, it's never considered de-energized until two things happen. They have to get a visible open point and also put this set of personal grounds on each side of the work area. That makes it protected for them, so they don't have to worry about the voltage coming back to them. While he's doing that, this device here right on the center pole, it looks like a transformer. It's actually what we call a recloser. And if you've ever been sitting at home and seen your lights blink, it's a good chance that one of these is what's causing that. What it does, it takes the source voltage and it feeds it through a section of line. If a fault gets on that section of line, whether it be a tree limb or whatever may be happening, that device is designed to open momentarily, then close right back up. That's why you see the blink. It attempts to close it back in. If that fault stays there after the third time, it will open up and your lights will not come back on until the utility gets out there and finds the problem and it heats it back up. He just closed in what we call a cutout or a fuse. It has a fuse inside it, which is another means of protection. And just whenever they get ready, we'll heat the trailer up. If you'll see right now, it's got a green light on it. That lets us know that we have our source voltage. When he presses this button, the red light will come on, and that lets us know that we have primary voltage on the trailer. All right, you got 63. So that's 6,300 volts is what we have on that trailer this morning. We're going to go ahead and talk about down lines and do this little doll demonstration here. I know all y'all believe are seniors now. You're all out driving. I have a 16-year-old driving, and it's a scary thing, you know, when teenagers start driving. So always, this is one thing we want people to be aware of. You know, this is little Susie. She just got her license, and she's done gone out and had a wreck. And if you'll see, she's got power lines on the car. Always treat any line down on a car or on the ground as if it is energized. Because it can be laying on the ground and it will not give you any warning. It's no sound. You can't smell it. You can't hear it. And it can be energized. So go ahead when you're ready. Right, when he heats it, he's going to heat this trailer up whenever y'all ready. And when he does, this car is going to be energized sitting right there. And this can be out in real life. I mean, she may just had a car, and we're going to show you what can happen if she decides to get out of that car or if somebody comes up to help her. Yeah, that's why it gives us no warning at all. It's sitting there energized, and there's no way to tell it. So if you ever are in any type of accident, or if you come across any type of accident and there's down lines, we want you to stay inside the car. Because what she just did when she stepped out, she became the path to ground. And we know there are some instances where you may have to get out of the car, say the car's on fire, you can't stay inside. If that's the scenario, we want you to jump clear. Make sure you jump as far as you can and keep your feet together. If any of you have ever thrown a rock in a pond, you know how the ripples go through the water? Well, that's kind of how this electricity does. If that electricity is going in the ground, it's got those ripples, what we call difference of potential, going out through the ground. And so if she steps in those different areas, she's going to get electrocuted. So always stay inside the car if you possibly can. If not, jump clear, keep your feet together, and then shuffle away in small steps or do bunny hops. We'll go ahead and do the fuse blow. Next thing we're going to talk about is a lot of people wonder why, hey, my lights went off but my neighbors are still on. We're going to show you a scenario why that can happen. What he's doing here is, go ahead and close the back jack too, Jonathan. He's closing these two cutout fuses to feed these back two transformers. And when he heats the trailer up, you'll see 2001 and 2002, those two lights will be on. That represents two houses fed by these two separate transformers. And we're going to show you why one transformer may go out and the other one stay on. What we got here, we got a little Rocky the squirrel. And this squirrel can actually represent a number of things. This squirrel is going to get on top of this transformer and blow that fuse. We found snakes on top of transformers. We found raccoons, owls, squirrels, birds, just pretty much anything can get up there can cause an outage. We're going to show you what happens whenever the squirrel decides to get on top of that transformer. That's what happens. And as you can see, what it did is it blew that fuse. The lights on 2001 are now off, but the lights at 2002 are still on. But what happened is exactly what's supposed to happen. That fuse is supposed to blow. What it does is it's a protection device that protects that equipment, and it allows it to be only a small outage, only one customer out compared to taking out the whole line. So what will happen is the lineman will come out there, take the old fuse down, refuse it, and just close it in. It's usually a fairly simple and easy, quick fix. So as you can see, you picked the lights back up at the other location. We'll do the 3-limb next. You can open that center jack. But that's exactly what it's supposed to do. Like I say, we'll have a lot of people call in and say, hey, my transformer just blew up. But as you can see, the transformer didn't blow up. The fuse barrel itself is the only thing that blew. So, next thing we're going to talk about is a little bit about tree limbs. I'm sure a lot of you and your parents have had guys come around wanting to trim your trees. Usually have a lot of angry people. But I just want to tell you, this is something that, we don't do it because we want to. We have to. It's a lot of people don't realize that actually wood can conduct electricity. It's not the best conductor, but we'll show you here in a couple of demonstrations that it will conduct it. So go ahead whenever you're ready. So he's going to put this is a green cedar that they cut off this morning. As you can see, immediately when you put it up there, it's starting to fuzz and arc. It'll start smoking. And if it stays in that line long enough, it's going to either catch on fire or it's going to cause an outage. And if you've got kids or anything running around in your yard, you definitely would not want them in the yard playing around this. As you can see, it's already done catching fire. And one other thing we can show you, he can take this, and you see that open cutout, he can take that piece of wood and he can jump out that switch. As you can see, he just heated up these back two transformers through that wood. So people don't think that wood is a conductor, but it shows you right there that it will conduct electricity. So that's why we come and try to trim the trees back off of the lines. Do the hot dog next. Next thing we're going to do is we're going to cook a hot dog. I would not recommend it. Hey, I tell you what, you can take a look at it if you really want to, but I would not recommend it. We use this hot dog because it's the best thing that we can come up with that kind of represents human contact. Yeah. All right, go ahead when you're ready. So that's what will happen if actually we have somebody make contact into a power line. We want to make sure that don't happen. That's why these guys go through many, many years of training to be able to get up there and work on it. If you'll look at that hot dog, what it does, it'll burn from the inside out. And what may appear to be not very serious in the beginning, after about a week it ends up being a very, very serious burn. And this person will be lucky if he lives, but at the very least he's going to end up losing arms or legs. So that's why the training is so extensive and takes so long. We'll do the ladder next. The next thing we're going to show is just your ordinary aluminum ladder. Of course, this could represent anything. It could represent maybe a TV antenna on top of a house. Always look up. Make sure there's no power lines anywhere. We're going to show you what can happen if you get anything aluminum or metal into the power lines.
That's cool.
As you can see, it draws a pretty good arc, and anybody on the other end of that ladder, it's going to get electrocuted immediately. So we'll make sure to always look up to live. Underground will be next if you want to open the transformers and hook up the underground. The next thing we're going to talk about is underground. You know, people say, why not just put everything underground? And we do have a lot of things that's underground. If you'll see this little setup we have here, this black wire with the red stripe, that's what we call an underground primary cable. Most of the time now we'll bury it in conduit, but a lot of your older installations are direct buried. But anytime that you're going to do any digging, make sure you call 811. That way they can come out there and do a locate to make sure there's no buried power lines, or of course it could be gas lines or anything like that as well. But we're going to show a demonstration here what can happen if you do dig into it. And I mean, this could represent, like he's going to be using the shovel, but even a backhoe. You know, if a backhoe digs into this, and say you've got a man on the ground leaning against that backhoe, it's going to electrocute him. Back up this a little bit.
You probably go up and grab it. It's all you.
Like I say, we got working inside here. We have several layers of protection. We have our hard hat, our safety glasses. We have our flame retardant clothing. We have rubber gloves. He also has rubber overshoes and standing on a rubber mat. So we have several layers of protection in here. So whenever y'all ready. As you can see, it draws a pretty good arc there, and even once that arc got started, he removed his shovel, the arc was still going inside the box. The last demonstration that we have, we're going to show a little bit about a generator safety. A lot of people don't realize it, but these generators, if they're not installed properly at your house, they can pose just as much danger, if not more, is what the linemen are to deal with. What we have is just a regular Honda generator that anybody can go out to Lowe's or Home Depot and buy it. We're going to completely isolate the trailer from a source. The only thing that's going to be feeding this trailer is that little generator. And what it's going to do, that generator is going to feed into 2001. We're going to hook it straight into that electrical panel. This customer has left his breaker on, which is going to allow that electricity to flow back through the weatherhead. It's going to come back and feed this back transformer. And again, just like we had a while ago, it's going to take 240 volts from that generator, and this transformer is going to step it up to our primary voltage. It's going to, in turn, it's going to feed that back transformer, and it's also going to pick up the neighbor's house, all by this one generator. Yeah, whenever y'all ready, go ahead. Susie's had a hard time. I don't know how many more of these she's going to be able to take, but she's hanging in there. Alright, whenever y'all ready. Alright, as you can see, he just started that generator and heated up the house through his electrical panel. His main breaker is still on, so what he don't realize is he's feeding back to this transformer right here. So whenever Jonathan closes this switch, he just put primary voltage back on that top wire there. Yeah, you can go ahead and close that gap first. And you can see even he can close this other transformer and going to energize this back house, all off that generator. And he'll go ahead and take the voltmeter and show us what kind of voltage is running off that generator. And like I say, if we've got some guys working on this power line and a homeowner installs one of these generators improperly, it's going to come back on them. And if they're not doing everything they're supposed to cause them to get electrocuted. Or say, if we had a tree fall, maybe this primary line is in a neighbor's yard, and they just energize that line up. You know, if the neighbor's out there working in his yard trying to get that tree trimmed up, you know, it could electrocute him as well. Again, he's going to take his voltmeter and just show what kind of voltage we're reading. Again, this is off of that simple generator that anybody can go out and buy. What is it? 6.6. So we actually got 6,600 volts on that trailer just from that one generator. And we'll go ahead and show one more hot dog demonstration just to show that we still got primary voltage off that generator. It'll pull the generator down, it won't be quite as strong, but you can see it's still real serious. Alright, usually after several tries it'll end up kicking this breaker. So.